discuss one of the important output which we always use in displaying the output, that is the display devices. So, today we will discuss the display devices. What are the display devices and how it works and how many types of display devices we can use in the electronic circuit. So, we start with the what is the display devices. Display devices is an output device for the presentation of the information in the visual form. Means we can display the output in the form of visual display, like if we are having the numeric value, then we will display in the form of the numeric value. If we have a graph, then we display in the form of a graph. So, any circuit which gives the output, we require the display on the device. So, for this we use the display devices. So, display devices is an output device for presentation of the information in the visual that will be used further for the application. Now, when the input information that is supplied has an electric signal, the display is called the electronic display. If we have a if we get the input information that is supplied in the form of the electrical signal, so we will call it also as a electronic display. We can say it is a display device, or we can say it is a electronic display device. And what is electronic visual display? Electronic visual display is a display device that can display images, that can display video, that can display the text that is transmitted electronically. Means we can get these output in the form of images, in the form of video, in the form of the text. Nowadays we use the display devices, like all the output will take on the desktop or the computer or the laptop setup. So, electronic visual display includes the television sets, computer monitors, or the digital signal devices. So, these devices, we can say that these are the mobile computing application where we use the tablet computers, smartphones, information appliances. Many electronic visual display are informally referred to as a screen, and that represent the display of the output of any electric signal. If we start from the 2000s, then the flat panel displays begin to dominate the industry, like the cathode ray tube. The first display devices was the cathode ray tube, that nowadays that is replaced with the flat panel displays. And for computer application nowadays we use the flat panel display. For starting of the mid 2010, then curved display panels begin to be used in the television, computer monitors, smartphone and electronic gadgets. So, there are the various technologies used for the electronic visual display, like electroluminescent display, like in that is also called the EL display. Second is a liquid crystal display. You all have listened that we are have a LCD, we are have a LED in our houses in the form of the television. So, liquid crystal display with the light emitting diode, that is LED, backlit liquid crystal display, that is a LCD. So, we are having many display devices. Apart from that, we are having a light emitting diode display, that will be the OLED display, and another is AMOLED display. So, most of the time we use in the electronic circuit, that is a light emitting diode to display the output. Another display is the plasma display, that is also called the P display. Now, another type of display is the quantum dot display, that is QD display. A overhead projector can be considered a type of electronic visual display that is also used for as a electronic devices. So, additionally, CRT, cathode ray tube, were widely used in the past, and micro LED displays are under the development. So, CRT that used previously, nowadays we are using the LED display for getting the output. Now, classification if we do, then electronic visual display present the visual information according to the electrical input signal, and it may be analog or it may be digital, either by the emitting light. Then they are called active display, or alternatively by modulating available light during the process of reflection or transmission, that is, a light modulators are called the passive display. It means we can differentiate or classify the electronic visual display into two forms. One is the active display, where we can get the electrical input signal in the form of output by emitting light, and another is the passive display, where we use the alternative by the modulating available light during the process of reflection or the transmission, or that is the light modulators that are called the passive display. So, we have the two type of the display unit. One is the active display unit, second is the passive display unit. In studying the various electrical network and the system, signals which are functions of time are often encountered. Such signals may be periodic or non-periodic in the nature. So, the device which allows the amplitude of such signals to be displayed primarily as a function of time is called the cathode ray oscilloscope, that is commonly called the CRO. You all have seen in your laboratories the CRO. Still we are using this CRO to display the output, and that device is the function of the time, that display the function of the time. So, CRO gives the visual representation of the time varying signal, the how the signal is varying with respect to the time. So, you have seen that we are having a display where we can have the graph, we have the graph and then we can trace the output from there. So, the oscilloscope has become a universal instrument and is probably most versatile tool for the development of the electronic circuit and the system. So, this oscilloscope is one of the electronic device, and that is most commonly used for getting the output that is connected with the electrical circuit. So, it is an integral part of the electronic laboratories, and the oscilloscope is in fact the voltmeter. So, CRO, cathode ray tube, is also known as the oscilloscope. So, instead of the mechanical deflection of a metallic pointer as used in the normal voltmeters, the oscilloscope uses the movement of an electron beam against a fluorescent screen. If we connect a voltmeter, then we are having a deflection in the voltmeter, but in case of the oscilloscope we use the we get the output in the form of the graph. How we will get the oscilloscope uses the movement of an electron beam against a fluorescent screen, which produces the movement of visible spot, and this movement of visible spot on the screen is proportional to the varying magnitude of the signal which is under the measurement. Means we are getting the variation of the magnitude of the signal that we are getting in the form of the output on the screen. So, what is the basic principle behind it? The basic principle is that the electron beam can be deflected in the two direction. One is horizontal, that is the x direction, and second is a vertical, that is the y direction. Thus, an electron beam producing a spot can be used to produce the two-dimensional display. You have seen there is a graph on the screen of the oscilloscope where we can get the plot of the x direction as well as the y direction. So, we can take it from there. Thus, the CRO can be regarded as a fast XY plotter, and the x and y axis can be used to study the variation of one voltage as a function of another. So, typically the x axis of the oscilloscope represent the time, while the y axis represent the variation of the input voltage signal. So, it is very clear that we are having a XY axis in the CRO, where x axis represent the time and y axis represent the voltage signal. Then we can get the output in the form of the point or in the form of the graph, and we use the electron beam there to get the output. So, it is very clear that we can get the XY plot in the CRO. Thus, if the input voltage signal applied to the Y axis of the CRO is the sinusoidal, wherein with the X axis represent the time axis, then the spot moves sinusoidal, and the familiar sinusoidal waveform can be seen on the screen of the oscilloscope, or the graph in the form of the various output, like in the like if we can get the hysteresis loop experiment, then we can get the output in the form of the hysteresis. Then in the form of the loop we will get output on the oscilloscope. So, oscilloscope is so fast device that can display the periodic signal whose time period is as small as microsecond and even the nanosecond. The CRO basically operates on the voltage, but it is possible to convert current, pressure, strain, acceleration and the other physical quantities into the voltage using the transducers and obtain their visual representation on the CRO. Now, what is this CRO and how it works, how we will how many parts it have, moreover how many parts we can define in the CRT and how we assemble them, how it work, how many type of cathode ray tube. So, we will discuss further. So, first cathode ray tube. This cathode ray tube is a heart of the CRO. The CRO having the cathode ray tube, one of the important part of the CRO. This CRT, this tube generates the electron beam, accelerates the beam, deflects the beam and also has a screen where the beam becomes visible in the form of the spot. Means this beam is very important, this which is the electron beam is important, which is inside this tube. So, the main part of the CRT are the cathode electron gun. Number one is the cathode ray tube having the main parts, in which first one is the electron gun, second is the deflection system, third is the fluorescent screen where we get the output or the spot, 4 is the glass tube or the envelope, and 5th is the base A. Schematic diagram we can see in the CRT, which show the main structure and the main component. You can see on the screen that this is the CRT tube, and here we are having the various part of the CRT tube. You see here left hand side we are having the base, and then we are having the deflection point where the cathode ray will move, and you can see there is a various part of the cathode ray tube. You can see on the we are having a screen on the right hand side, that is the fluorescent screen where we can get the emission of the electron takes place. Bright spot we can, visual light, visible spot we can get it here on the screen. So, this is the basic representation or the block diagram of the CRT tube. So, you see that at the last we are having a, on the left hand side we are having a pin, that pin attached with the that will connect with the another device that we will put in the CRO or the oscilloscope. A particular voltage is supplied just to for the deflection of the electron beam coming out from the cathode. Then that light we will get on the that electron beam we will get on the screen. So, the first part which we will discuss, that is the electron gun. What is this electron gun? Electron gun section of the cathode ray tube provides a sharply focused electron beam which directed towards the fluorescent coated screen after multiple deflection. So, this section start from the heated cathode and then limited, and then it is having the limiting electrodes. This control grid which is given the negative potential with respect to the cathode DC, and this grid control the number of electron in the beam going towards the fluorescent screen. Means by control grid we can control the number of electrons which is going towards the screen. So, when the electron gun generates the electrons, then in between that we are having the control grid. That control grid control the number of electrons which is moving towards the screen. The movement of the electrons, their number x, their speed determines the intensity or the brightness. The movement of the electron determines the intensity, brightness and the light emitted from the fluorescent screen due to the electron bombardment. So, the light emitted is usually of the green color. So, because the electron are negatively charged, a repulsive force is created by applying a negative voltage to the control grid, and the CRT voltage applied to the various grids are started with respect to the cathode, which is taken as a common point. So, this negative control voltage can be made visible towards the fluorescent screen. Next system is the deflection system. That deflection system is used for deflection of the electron beam. When the electron beam is accelerated, it passes through the deflection system. When it is accelerated, electron beam accelerated, it passes through the deflection system, with which the beam can positioned anywhere on the screen. It means by deflection, by this deflection system, we adjust the movement of the beam and we positioned the beam on the screen by this deflection system. The deflection system of the cathode consists of the two pairs of the parallel plates referred to as the vertical or the horizontal deflection plate. So, one of the plate in the each set is connected to the ground to the other plate of the each set. So, the external deflection voltage is applied through an internal adjustment gain amplifier stage to apply the deflection voltage externally. An external terminal, that is called Y input or the X input, is available. So, through this deflection of if we get the deflection, then the deflection voltage is adjusted accordingly, so that a deflection point can be adjusted at a particular point which is the requirement. So, the electron beam passes through these points. A positive voltage applied to the y axis terminal, so that is the B, that we can say it as a V y, that causes the beam to deflect vertically upward due to the attraction forces, while the negative voltage applied to the y input terminal will cause the electron beam to deflection vertically downward. If we want the deflection beam, or we want the electron beam vertically up, so we use the deflection through the that will be due to the attraction of the forces of the negative voltage applied. But if the positive voltage applied, then the vertical downward we will get. So, due to the repulsion forces, in the previous we have the attraction, and in the repulsion, that is towards the downwards. So, when the voltage are applied simultaneously to the vertical and horizontal deflection plates, the electron beam is deflected due to the resultant of these two voltage. Means when we get a deflection, when we want to deflection vertically upwards, it is only due to the attractive forces, where the terminal, while a negative voltage applied to the Y terminal will cause the electron beam to deflected vertically downward due to the repulsive forces. So, when the voltage are applied simultaneously, then the deflection will be the resultant of the horizontally plate or as well as the vertical plate. Next part is the fluorescent screen, that is the display screen. The light produced by the screen does not disappear immediately when bombardment by the electron ceased. That is, when the signal becomes 0, then when the signal becomes 0, the time period for which the trace remains on the screen after the signal becomes 0 is known as the persistence. Means when the signal is there, then we can get the output on the screen. When it is not there, then when it is the signal becomes 0, then still if it is the value for tracing, then it is called the persistence. So, persistence may be just short as a few microsecond or as long as 10 seconds. So, long persistent traces are used in the study of the transient. So, long persistence helps in the study of the transient, since the trace is still seen on the screen after the transient has disappeared. What are the phosphorus screen characteristics? As we say that the phosphor screen we are using for the displaying. So, what are its characteristics? Many phosphor materials having a different excitation time and color, as well as different photophosphorescence time are available. And you see in the laboratories we are just having the green color output. So, type P1, P2 and P3 are the short persistent phosphors and are used for the general purpose oscilloscope. Medical oscilloscope require a long phosphor decay, and hence phosphors like P7, P39 are preferred for the applications. Very slow display like radar require the long persistence phosphors to maintain the sufficient flickers, free pictures. Such phosphors are the P19, P26 and P33. So, on the basis of the phosphor we can just have the output display. So, the phosphors P19, P26, P33 have the low burn resistance. So, we can get the display in the slow manner. The phosphors P1, P2, P4, P7, P11 have the medium burn. So, persistence, while according to the P31 having the high burn resistance. Now, you see this is the simple block diagram of the oscilloscope. You see there is a input. First we are having a vertical amplifier. After that there is a display line. That display line is connected with the voltage. You see on the left hand side there is electron gun which produces the electron. There is a voltage applied horizontally and vertically. Inside the tube you will see V, V and H, H. You see here we are applying the voltage vertically and horizontally. The electron will pass towards the fluorescent screen. Now, here on the left hand side, here we are having the trigger circuit that is connected with the vertical amplifier. After that, time based generator, because we are getting the time and voltage output. Then it is connected with the horizontal amplifier that give the output, and then from here the high voltage or low voltage output we will get and we can get the display in this. So, CRT, this is the cathode ray tube which is the heart of the CRT. It is used to emit the electron required to strike the phosphor screen to produce the spot for the visual display of the signal. That is the CRT we are having on this tube, that is where we are having electron gun. This is the CRT tube. Now, further we will discuss the other parts of the cathode ray tube. Thank you very much.